Welcome for the next class. Today's class will discuss about the instructions of 8086. So all the 8086 instructions are being divided into different categories. They are data transfer instructions, arithmetic and logical instructions, program control transfer instructions, machine control instructions, shift and rotate instructions, flag manipulation instructions, and string instructions. These are the 7 different categories. So all the 8086 instructions are divided into. So the data transfer instructions are responsible for moving the information from one place to other place. So as a result, they are called under data transfer. The second group, arithmetic and logical, will perform all arithmetic operations and logical operations. The program control transfer instruction group. So all the instructions in this group are responsible for program deviation from one sequence to other sequence. Machine control instructions will control the processor behavior. Those instructions are classified into this category. So shift and rotate instructions will perform the shift operations, shift left, shift right, and rotate left, rotate right. Rotate is nothing but circular shift. Then flag manipulation instructions. So these instructions are used to change, modify the flags information. And for string operations, string instructions are used. These are the different categories. So we will see one by one group. First, we will see the data transfer instructions. These are the list of the data transfer instructions: move, push, pop, exchange, in, out, translate, load effective address, load DS, LAHF, SAHF, push F, and pop F. These are the different data transfer instructions. All these instructions are responsible for sending the information from one place to other place. So in this, the source content remain unchanged, only the destination content will be updated with source content. That is the operation performed in the data transfer group. So first instruction is move, say bx comma 00 f2h. So in this case, that 00 f2 is the data, immediate data is transferred into bx register. That is, bh register will have 00 and bl register will have f2. Whatever content were there in bx register will be overwritten with this 00 and f2. That is, move bx comma 00 f2. The second instruction, push cx. In this case, push cx, the content of the cx register will be stored on the top of the stack. So in this particular case, contents of cx register will be transferred onto the top of the stack. So with this, what it does is, first it is going to, so suppose if this is the stack area, say if the stack pointer is pointing to this particular address, then with push cx, the stack with push cx, stack pointer will be decremented by 2, then top of the stack, will get the content of cx register. That is what the push operation is. Next, pop is the reverse of push operation. So pop cx, the top of the stack content will be transferred back into cx. So here what it does is, first, so cx will get content from top of the stack, then stack pointer will be incremented by 2. So this is quite opposite to the push operation. Now next is exchange bx and cx. So here the contents will be interchanged. Suppose before the instruction, say bx is having 0005 and say cx is having 1005 for example. So after executing the instruction, Bx will have 1005 and Cx will have 0005. That is the meaning of exchange, interchanging of the contents between the registers. The exchange is being used. Next, in AL comma 0F8. So, in this case, the content from the 0F8 is the address of IO device. Say especially it is called an input device. 0F8 is the address of input device. From this input device, the content will be transferred into accumulator. That is in AL comma 0F8. Out to DX comma AL. The next instruction is out to DX comma AL. In this case, now the DX is acting as a pointer to the output device. Pointer to output device. DX is a pointer to output device. The content of DX is nothing but the address of the output device. So, the information present in the accumulator will be transferred to the output device specified by DX, that is out to DX comma AL. So, if the output in-out devices address is of 8 bit, we can use the direct addressing like this in AL comma 0F8 if the IO address is 8 bit address, and if the IO address is 16 bit address, then direct addressing mode cannot be used, only indirect addressing mode to be used, that is the IO address is to be stored into the DX register, then the DX register is to be used in the instruction with in or out. That is about the IO devices, data transfer between accumulator and IO devices. Next is translate. So, this translate instruction is specifically used for converting the codes, code conversion operations. The translate instruction is used. Suppose I want to get, say, a BCD 7. For this I want to get the code, 7 segment code. For 7 segment code for BCD 7 if I want, then what I will do is, so 7 is the input I will give, then I am going to get 7 segment code for this 7 with translate instruction. For that what we are going to use is a lookup table is being used. Lookup table. This lookup table is being stored in memory, okay, and its offset address of the memory is stored in the BX register, and the specific key number is stored in the accumulator. Then the translate instruction, what it does is, it will calculate the effective address of the lookup table with, so the 10H into data segment plus BX plus AL. So, whatever code is there in this location will be copied back into AL. That AL content will be the, so 7 segment code for say BCD 7 number, for example. So, likewise we can have the code conversions as a lookup table, and that lookup table is stored in the memory specified by the BX with offset address and exact code through AL. So, that is the use of translate instruction. The next instruction is load effective address. So, load effective address into a particular register, say BX. So, the offset address of the memory location is being copied with into BX. That is the use of load effective address. The next instruction is load DS or load ES. So, we may be giving the instruction load DS, say BX comma say 5000 for example. If this is the instruction being given, so from this, suppose in the memory, so in the memory, for example, this is say 5000 location and 5001, 5002, 5003 in this. So, content of 5000 and 5001 is being copied into BX register, and 5002 and 5003 content will be copied into DS register. So, the instruction is load data segment register and the BX register from 5000 location onwards. That is the meaning of this instruction. So, 5000, 5001 is copied into BX, 5002 and 5003 content will be copied into DS. Similarly, LES say BX comma 5000. So, load extra segment with and BX with 5000 content onwards. That is BX will be copied from 5000, 5001 and extra segment copied from 5002 and 5003 if it is LES BX comma 5000. That is, so load data segment, load extra segment, that is instructions. Next is load AH register from lower part of flags register. So, load AH register from the lower part of flag register. That means, this instruction will get content of flags register, lower byte of flags, lower byte of flags register is copied into AH register. That is the meaning of load AH from flags. The store AH to flags. So, this is the reverse of this. That means, the content of lower byte of flags register will get the content from AH. The information of AH is copied into lower byte of the flags register. So, generally, suppose we want to manipulate any of the flags of information, then by using LAHF, the lower byte flags information is being copied into AH and that can be manipulated depending on the requirement. After manipulating again from the AH, it can be copied back to the flags register. So, for that purpose, so this load AH from flags and store AH into flags instructions are being used. The next is push F. So, this instruction will push the contents of the flags onto the top of the stack. Contents of the flags register will be pushed onto the top of the stack, that is push F. Pop F, the top of the stack contents will be retrieved into flags register. So, it is similar to push and pop instruction, but here the specifically the source for the push is flags register and for the pop flags register is the destination. So, that is how. So, these are the different data transfer instructions that are being used. Okay. So, I will stop at this point. We will continue in the next class and some other topic like arithmetic instructions.